is one of the final topics on waves, and we're dealing with a very specific type of wave. We're dealing with an electromagnetic wave, and often given the term EM waves for short. Again, electromagnetic waves. Now, we talked about light waves before. If you want to give an example of a transverse wave, we always use an electromagnetic wave as an example. Now, light is an example of an electromagnetic wave. And interestingly, light can travel through a vacuum. It's the way that the Earth is heated from the sun. There's no other way that the heat can reach the Earth from the sun. So what on Earth is vibrating? Because if you remember from the video on sound, we said there were no particles in space, so nothing were to vibrate, so sound won't travel in space. However, it can travel through space, so what is vibrating? Well, the answer is simply electric fields. And magnetic fields. And those are all around us all the time. So therefore they travel through space, travel through us, all around the whole universe. There's always electric and magnetic fields. So if you're able to cause a vibration, and the vibration is always at right angles to the direction, then we'll remember that that produces a transverse wave. And this is a really good example. Electromagnetic wave, any of them, which I'll list in a minute, any of them are a great example of a transverse wave. Interestingly as well, they all have the same speed. And that is the speed of light, which is often given the symbol c, which is 3 times 10 to the 8 meters per second. Super fast. 300,000 kilometers per second. That is going from here to the moon in 1 second, or here to the sun in 8 minutes. Pretty fast. Now, of course, the number of vibrations with respect to time, the frequency of the vibration, or the wavelength of the vibration, can vary quite considerably. We can either have something which is incredibly long wavelength, or we can have something which has a much shorter wavelength, or we should say a higher frequency. This is when it starts to get a bit complicated and a bit messy. Okay. So here is our complete range. So we have what is, I suppose, this way increasing in frequency. This way increasing in wavelength. However, all of it travels at the speed of light, the same speed, but they're all incredibly different based on just those simple changes in frequency and wavelength. And they're divided up into 7 regions of the electromagnetic spectrum. Now, one of those regions, before I divide them up, let's just have a quick little example. I know that one of those regions has a wavelength of 3 times 10 to the minus 7 meters. We know the speed. What's the frequency? If you think you can know, obviously you need the wave equation for this, which we did in the previous topic. If you think you know, hit pause and work it out. Otherwise, here comes the answer. Well, we know that the speed is the frequency times the wavelength. So therefore, the frequency is the velocity divided by the wavelength, which gives us 3 times 10 to the 8 divided by 3 times 10 to minus 7, which gives us 1 times 10 to the 15 15 hertz. Sorry, that's so small. Frequency measured in hertz. Okay, good. So you're going to need to feel comfortable with manipulating those. However, of our electromagnetic spectrum, we have seven regions. Sorry. We start with the longest, which are radio waves. And what you thought might look quite obscure, you'll notice that these are things we use every day. Then we go to the microwave. As it gets slightly higher frequency, shorter wavelength. Then infrared. Then we turn to the visible. Then we go to the ultraviolet. Then we turn to the X-rays. And finally the gamma rays. Okay, so those are our 7 regions. Gosh, I hope there's 7 now. I said 7. Yes, those are the 7 regions of the electromagnetic spectrum. And all of them have uses and dangers. And we're going to look at the uses and dangers of each of them. You'll probably see them in class, we'll probably have some demos of them, but you'll need to be able to repeat the uses and the danger of them. And of course, these loosely apply to these types of region. Okay then, so there we go. I'm not sure of a very good acronym to learn to work these out. R, M, I, V, U, X, G. If you can think of a great one, let me know about it. That'd be good. Okay, first of all, uses. Well, radio waves used for communications in general. Whether it is radios, or televisions, or or telephones, and I say that not mobiles. But any type of communication is a radio wave. There are 2 major uses for microwaves. One are mobile phones. I mean, the reason why you have such a long aerial for your radio and such a tiny one built into your phone is because the radio is picking up the longer wavelengths, which are approximately 1 meter-ish, 10 kilometers to 1 meter. Whereas the microwave is approximately in the centimeters. So you have a much smaller phone. Also, we use these for cooking. But that's with microwave cookers. Good. What about infrared? Well, infrared is anything which comes off something which is hot. So if an item is very hot, it gives off infrared. It's actually what's used in toasters, controllers, like TV controllers and things, and also so not only toasters, but also if you're cooking something with heat, so like a fire, it's the infrared which causes it to be hot. Okay, visible might seem obvious as a use you can see, but how about microscopes, and telescopes? Really useful uses of visible. This is approximately 10 to the minus 7 meters, talking super small. That was my example there. 10 to the 15 hertz is approximately ultraviolet light. Okay, what about ultraviolet? Well, ultraviolet, I suppose, is it a use? Is it a danger? You can use it in for tanning, sun tanning. And also, it can be used for security systems. You have a UV pen which glows, so security tagging. And also credit cards and money all have ultraviolet tags on them. What about X-rays? Well, use of it, you can obviously seeing inside the body, X-ray pictures, but also you can use it to kill cells. And if those are harmful cells, killing cells is very useful to use with X-rays. Right, gamma rays, you can use in medical therapy for the same reason, for killing unwanted cells. But also gamma rays is used for sterilizing medical supplies. So if you had, let's say, a knife, a scalpel, which you need to use in a surgery, you'd place it in a plastic bag, you'd hit it with gamma rays, and then anything inside there dies, including all the harmful bacteria. So next time you bring it out in a clean medical theatre, it's completely sterilized. Okay, now, when it comes to dangers, increasing frequency actually causes an increasing in energy. So though radio waves are very unharmful, gamma rays are incredibly harmful because the energy they pack is so much greater. So whereas radio waves have very little to no danger, microwaves heat water, and any dangers associated with them are because they heat up the water, and your body, of course, doesn't like heated water. You're homeostatically trying to keep your own body temperature, that's why it causes problem. Infrared can burn skin, and you've seen what happens to a piece of toast in a toaster. But careful not burning it in the sense of ultraviolet, because ultraviolet burns skin in a cancerous sense, in that it gets into the skin, so it burns skin. What did I say? Melanoma type of way? No, it burns skin by yes, sunburn. Whereas actually, this is burning skin stroke overheating. If you leave a piece of toast in too long, this is burning skin, getting a tan. Visible damages eyes. They always say don't look at the sun directly, otherwise it'll damage your eyes. Of course. X-rays kill cells, and that's a problem. That's why they no longer X-ray your feet to see if your shoes fit, because it's killing cells. However, medical professionals decide whether killing the odd cells is preferential to seeing inside the body and working out what's going wrong or right. And gamma rays, of course, indeed kill cells for the same reason. Now, that is pretty much all you need to know about the electromagnetic spectrum. You just need to know that essentially it is a transverse wave travelling at the speed of light. There's 7 different regions with uses and dangers. It's quick fire, it's just an add-on to what you've already learned.